Hello everyone and welcome to this video lecture. In this video lecture we are going to have a look at how to create new arrays or new NumPy ND arrays which are made of ones and zeros. So let us get started. So before we get started we will just save this file, or we will just rename this as section 09 because this is the section 09 of our training course. So I just save it, and the very first cell will have customary markdown because we just want to have rich text in our notebook so that when I make all these notebooks available to you for download, you will be able to understand what code is meant for what video lecture. So if I just execute this, it is going to print ones and zeros in heading 1. Now let us import NumPy. Import NumPy as NP. Let's have a look at the first routine. So x equals to np.empty. So this routine creates an empty array and initializes it with random elements. So we need to provide the size of the NumPy array. We also need to provide the data type. So let's keep it as unsigned integer of 8 bits. So the values will be limited from 0 to 255. So if I print the value of x and execute this, you will be able to see that a n-dimensional array of 3x3 size with random values has been initialized. We can also have another type of array with the function eye, that is I 3, t type equal to np.uint of 8 and print of y, print y. So if I execute it, it creates an array where all the diagonal elements are 1. Now we can shift the position of this diagonal by adjusting or by providing the correct argument. So I will just say k equals to 1 and let us see what happens to the position of diameter, or sorry, the position of diagonal. So before that we can just change the size so that it will be easier for us to understand, and we will even change the size of this and rerun this. So if I rerun it, I can see a 5x5 matrix. Similarly, if I execute this, I will still see 5x5 matrix, but as you can see, the position of diagonal that contains the elements 1 has been shifted upwards. Similarly, if I execute this query with k equals to -1, you can see that the diagonal has been shifted downwards. Now we can even create an identity matrix with x equal to np.identity (5, d type equal to d type equal to np.uint of 8, and I will print the value of x. So this creates an identity matrix where all the diagonal elements are 1. I can even create a matrix of ones. It's very easy. Let's say x equals to np.ones and 2, 5, 5, d type equal to np.int16 print x. So if I execute this, I will be able to see a 3-dimensional matrix of size 2, 5, 5. We can even create a matrix of zeros in the similar way. Just need to replace this ones with zeros. So these are all the routines that help us creating the matrix, the kind of matrices that we want. And these are very important because many times in scientific and numeric computing, we need to use very big matrices that are either filled with zeros or ones. So in the last lecture, we saw how to create NumPy arrays with the kind of elements that we want. So hadn't these functions been available in NumPy library, we would have to create all these matrices manually, and it would have been like very, very difficult, because suppose if you want to create a matrix of size 100 into 100 into 100, then it would have been like very difficult for us, correct? Because we would have to define all these elements and then row by row, column by column, and dimension by dimension. It is kind of very, very tedious task. So we can just go ahead and create these matrices in a single statement. So that is very convenient for all of us. So if I execute this zeros function, it creates a 3-dimensional matrix of given size, okay, or any n-dimensional matrix of given size. So if I just say comma 2, then let us see what it does. As you can see, it has created a 4-dimensional matrix of the given size and with the given data type, and the all elements in that matrix are 0. Finally, x equals to, we will just copy that entire earlier line and we will just make full. Okay, so for the sake of simplicity, let's keep it 3, 3, 3. Data type is np.int16, and finally field value equals to 2 or 3 or whatever we want to have as field value. So it is going to create a matrix and fill all the elements with this value. So we are printing this matrix or this particular multidimensional data structure, and you can see here a 3-dimensional data structure with all the elements filled with the field value. You can even make it 5, and let us see how it works. So this is how we can use various functions like empty, I, identity, ones and zeros, and full in NumPy library to create the matrices that we want for our scientific as well as numerical computations. Do let me know if you have any queries or questions related to all these routines. Thanks a lot for watching this video lecture, and see you all in the next video lecture.